the torque for an engine, means for a vehicle, and how the torque is being provided. That is where this slide comes into picture. You know, this is the characteristics of an engine. The engine speed is given in x-axis, and the engine torque is given in y-axis, and one more axis with engine power. You can see you can see the graph where the rated power is been achieved only if you have the rated torque. Okay, but what happens, unfortunately, uh, there are some limitations with respect to the engines where it cannot provide the sufficient torque at near zero speed. When the speed is zero, the torque you cannot provide, the engine cannot provide the required amount of torque. Okay, and hence you need to have a move of element such as clutch, and in order to increase the clutch and gearbox, where you can have the high torque at the initial zero speed, also non-zero speed basically, where the vehicle can run at 800 rpm or 700 rpm, where you need to have the high torque. Okay, and it can provide a maximum power only at a particular speed. Hence, it cannot meet, the engine cannot meet the ideal traction hyperbola. So this, you can see that hyperbola condition. This is hyperbola, and hence we need to have a multi-speed gearbox. And the fuel consumption is also depending upon the operating point or the operating state, where with respect to the high power to weight ratio or high energy density fuel, or with respect to the torque point of view. Okay. So you have two speed, engine speed depending upon the angular torque and also the angular power. So considering the angular power, so you have the P max, and angular torque you have the torque max, and this rated torque or the maximum torque you can achieve at non-zero RPM or non-zero engine speed only with the help of the move of element called the clutch or the gearbox. Okay. So we have seen driving shaft and also the driven shaft, right? So, and you also have the gear. With respect to gear, you have driving gear and you have the driven gear. How normally the gear ratio you call, or how you are going to calculate the gear ratio? Okay. Say for example, the driving gear is going to have 25, number of teeth is going to be 25, and the driven gear is going to have the number of teeth as 50. Then the gearing ratio is defined as number of teeth on the driving gear to that of the number of teeth on the driven gear, which means 25 by 50, which is nothing but 0.5. The gear ratio is going to be 0.5, which is defined as the ratio between the driving gear, number of teeth on the driving gear to that of the number of teeth on the driven gear. Which means it means for every one complete rotation of the input gear. Okay, so you have the driving gear is nothing but input gear, and the driven gear is nothing but output gear. So for one complete rotation of the input gear driving gear, the output gear will be rotating half of that. This is the typical layout of 5-speed gearbox. So I will start with the 3-speed, 4-speed, then I'll go with the 5-speed, but just a layout how it looks, just for an example. So this is how when the first gear is engaged, it looks like this. This is for the first gear, and this is for the second gear application. This is for the third gear application. This is the input gear. You have the fourth gear and this is the fifth gear. And you also have the reverse idler gear. But this is just a layout. You have the shaft, input shaft. This is nothing but the delay shaft or the counter shaft. This is nothing but the output shaft. Okay. See, This is a typical gear, say for first gear, second gear, third gear, fourth gear, and fifth gear. So we have seen the gear ratio. What is the gear ratio? Input. You've seen the example of a gear ratio, right? The ratio between number of teeth on the in gear driving gear to that of the driven gear. Similarly, for each and every gear shift, you have the number of gears, and you need to calculate the gear ratio. See, when the engine is when the vehicle is running in the first gear, the gear ratio is going to be say the speed at which it operates is, say for example, 947 rpm, and the maximum speed of the engine is 3000 rpm. Okay, and when you're running the vehicle at 947 rpm, it is equal to that of the 947 rpm of the engine, that the gear ratio is going to be 3.1:1. And in the case of second gear, it is going to be the gear ratio gets reduced when the number of gears are getting shifted from low to high. You can see the fourth gear is almost one is to near to 1:1. Okay, where uh, the input shaft is directly connected to the speed at which it rotates, and it also rotates 1:1. But there will be slight losses, but it will be close to 1:1. And you have a last gear called fifth gear, where the gear ratio is going to be very much lesser, and the speed is also to get increases. So higher the speed, you go need to have the high number of gears. Okay, so for example, when the vehicle is going to needs to run at 4000 rpm, you need to run the vehicle at 50 gear, and the gear ratio is also going to be lesser. Okay, you also have different gears. You spur gear, helical gear, double helical gear. You have warm gear. Okay, so we are going to see those things as well. What are different type of gears we have, and you also have the final reduction gear where it is present in the differential. It also have a high value, and this final reduction gear has a value which is something between 4.4:1 to 6:1. And from here, the drive goes directly to the wheel, and then it determines the actual velocity of the wheel at which it goes. And I have been telling you about this shaft, input shaft, counter shaft, and this is going to be the output shaft. This output shaft is connected to the differential, and this input shaft is coming from engine shaft. So when you're considering the typical front engine mounted rear wheel drive, okay, you will have basically three shafts: engine shaft, which is an input shaft, counter shaft, or lay shaft, and the last one is going to be the output shaft. And I told you you have three type of gearbox: sliding mesh gearbox, constant mesh gearbox, and synchronous gearbox. Okay, and in the case of synchronous gearbox, we are going to have a synchronizer which will help to engage the two gear on the output shaft. Okay, whereas in the case of constant mesh gearbox, we have a dog clutch, and it is going to get constantly in mesh with the output shaft. In the case of sliding mesh gearbox, the gears will be sliding each other. So we are going to see those different types of gearbox as well. Okay, so the first is going to be the sliding mesh gearbox. This is the layout. You have the input shaft, you have the counter shaft, you have the output shaft, and you have the gears which will slide. The name itself indicates sliding mesh gearbox, which means the gears will slide each other. Just look at this. When you're moving the gear from neutral to first gear, you can see that this is the first gear and this is the second gear. Third gear moves towards left, and reverse gear will move towards right. Okay, and it is having different gears like gear 1, gear 2, gear 3, gear 4, gear 5, gear 6, gear 7, and gear 8. Okay, different gears are there. This is basically for a 3-speed sliding gearbox layout. Now, doing the first gear, what happens is first gear is the one where okay, you see here first gear. Okay, we're doing the first gear. What happens? It move towards left, which means the gear 5 will move left. Okay, and this will mess with means this will get engaged with gear number 4 and the power flows. You see here the power from the input shaft goes to the gear 1 and it goes to the gear number 2 and it goes to the gear number 4 and it goes to gear number 5 and goes to the output shaft. Okay, now say for example when the vehicle is running at 1000 rpm in the input shaft. Okay, this 100 rpm 1000 rpm in the first when the vehicle is running at when the input shaft is running at 1000 rpm in the gear 1, the gear 2 will have some reduction because the number of teeth is going to be more when combined to that of gear 1. So it is going to be the gear reduction is going to happen. Say for example, it will operate at 500. And again, when it goes to the gear number 4, further the speed reduces from 500 to 200. And when it moves to the 4 to 5, uh, slightly you can see there will be a slight increment is going to happen again. So it will run at say for example of 300 rpm to 350 rpm and it goes to the output shaft. Similarly, now what happens? See, this gear ratio is also depending upon the speed at which it rotates. It also depends on the number of teeth. That's why we have seen the gear ratio, right? Gear ratio is nothing but the driving shaft to that of the driven shaft. So you have the driving shaft which is nothing but the input shaft and driven shaft is nothing but the output shaft. Okay, so based on that you calculate the gear ratio. So now again, this is the sliding mesh gearbox when it is operating at the second gear. You can see the power flow how that happens here. So when the during the second gear, during the second gear, what happens? The gear 6. This is the gear 6. It moves towards right. This gear 6 moves towards right, and this engages with gear 3. Okay, and you can see the power flow 1 to 2, 2 to 3, and 3 to 6, and goes to the output shaft. And now coming back to the third gear shift. Okay, what happens here? This is the final means this is the direct drive. You can see the teeth, the gear teeth of this 6 gear will be engaged with the clutch means the clutch shaft gear and the power flows directly. This is for a 3-speed gearbox. Okay. Similarly, you can have the direct drive for a 4-speed gearbox at the 4th gear and the 5th gearbox, 5-speed gearbox at the 5th gear. And normally, theoretically speaking, the gear ratio should be equal to 1:1, but there will be slight losses at the output shaft. So that's why the gear ratio is not going to be 1:1. It can be 0.97 or 0.98 or 0.9 close to 0.99. Okay, and it will vary with respect to the different speed gearbox. So what I have shown initially is a 5-speed gearbox where it will have 0.97 as the gear ratio at the direct drive, and it can be 0.98 for a 4-speed and 0.99 for a 3-speed gearbox. You have the reverse gear. So when the reverse gear, what happens? This gear 5 will move towards the right, and this engages with gear 7 and gear 8. I will tell there is an idler gear called gear 8, which is being used for a reverse application. When the vehicle, when the shaft is running at counterclockwise here, what happens? When it comes from gear 1 to gear 2, it rotates at the clockwise direction. And when it reaches 7, it also rotates as clockwise direction. And when it comes to the idler gear, it rotates in a counterclockwise direction. Okay, that's where the reverse application comes into picture. Okay, and again it goes to there, and again it operates in opposite direction. That's where the role of idler comes into picture. Okay, this is being used only for the reverse application. This idler gear, when it been moved, this 5 will move towards the side, and this will engage with the idler gear, and that's where the reverse operation comes into picture. See, nowadays this sliding mesh gearbox is not being used because what happens, that the gears which is sliding each other, it results in the number of breakages, and the gear teeth gets break often, and it also creates a lot of noise. Okay, when this gear and this gear is engaged, or the other gears are getting engaged, it calls for a lot of losses and noise operation. So that's why we're not going for this type of sliding this gearbox in normal operation. So we are going for the other two type of gearbox application. One is going to be the constant mesh gearbox, where the gears are always in constant mesh with each other. You can see the gears 1 and 2 are in mesh, 3 and 8 are in mesh, 4 and 7 are in meshed together, and 5, 6 are meshed together. Okay. So here in this case, we have the dog clutch D1 and D2 dog clutches, uh, where whenever there is an engagement between the gears, it is not going to be noisy, but even if there is a breakage, the breakage is not going to happen uh, to the complete gears. So here what happens, it's not just in this sliding mesh, the gears gets affected, the breakage happen. But in this case of dog, you have the dog teeth. Only dog teeth will get affected, but gears will not get affected. Okay, even it also saves the cost as well in case of any failure. And comparatively, the operation is not that much highly noisy operation when compared to that of sliding. And this is how the power goes for a 3-speed gearbox. For a first gear, when it is operated, the gear 1 will get engaged with the gear number 2, and then 4 to the output shaft. So this is the low gear. When the first gear, what happens? The stock clutch D1 will move towards left, and when this moves left, 7 and 4 gear will get engaged, and this is how the power or the gear transfer happens. So next is going to be the second gear. In this second gear, dog clutch D2 will move towards right such a way the gear number 3 and the gear number 8 will miss, and the power goes such a way 1 to 2, 2 to 3, 3 to 8 to the output shaft. Okay, and this is the third gear. And I told this third gear is going to be the direct drive where the input is connected to the output shaft. And in this case, what happens? The sliding dog clutch will move towards left. Similarly, in the case of sliding mesh also, we have seen the gear will move towards left where the third gear is going to happen. In the case of sliding mesh, okay, even the sliding mesh also, you can see the third one will move towards left. This will connect directly to the input shaft. Again, you have the reverse gear. When this is moving at a counterclockwise direction, this will move at clockwise direction. And finally, when it comes to the output, this also moves at counterclocks because you have idler gear which will reverse the operation from counterclockwise to the clockwise to the counterclockwise. Okay. And during this condition, what happens? The dog clutch D1 again will move D1 towards the right direction, and in this case, the idler gear will miss. Will have a constant miss. Okay, that is for the 3-speed gearbox what you have seen. Now, same constant miss for can also have the 4-speed gearbox. And this is how the dog clutch. In the case of sliding mesh, you have the sliding gears. In the case of dog, you have the dog clutch. You have one more clutch called a synchro mesh, where you have the synchronizer in between this one. And you have the input shaft, you have the dog clutch, you have the output shaft. This is the idler gear. This is the lay shaft. Okay. And let us see how the power goes or the gear gets transferred from one gear to another gear. So this is the neutral gear. The neutral gear, what happens? This is the input shaft and it goes to the lay shaft. There is no contact between the input shaft to that of the output shaft, or lay shaft will not connect to the output shaft in the case of neutral gear. Okay. Now let us go to the first gear. Okay, the gear from the first, it flows like this, and it moves in this way. Say for example, here you have the dog clutch here. This dog clutch will move towards right, and the power happens, means that the transfer of the power from the gear 1, 2, 3, 4, it happens in this way. Okay. And similarly in the second gear, this dog clutch will move towards left, and this engages with this one, and the power goes in this direction. And you have the third gear where the dog clutch of this dog clutch will move towards right direction, and the lay shaft is connected to the output shaft, and the gear of output shaft and the lay shaft will get engaged, and the power goes like this. And when I say power, it is nothing but the movement of the gears at different speed, okay, depending upon the number of teeth. And finally, you have the fourth gear. It is the direct drive where this dog clutch will move towards left and it goes like this. Okay, in fact, you also have the fifth gear in some application. And this is the reverse gear where the idler gear will get engaged, and this is how even the dog clutch also moves such a way that it will bring the idler gear in contact with the counter shaft and also the output shaft. This is the typical 5-speed constant mesh gearbox. Is also been used nowadays in high-speed application, where you have the clutch input shaft. This is nothing but the lay shaft or a counter shaft. You have the output shaft. So you have different gears like first gear, second gear, third gear, fourth gear, fifth gear. Okay, and you also have a reverse gear as well. And these gears are being shifted, means are transmitted based on the fork mechanism. You have a selector fork where when that's why when you move the vehicle from neutral to the first gear, that transformation is going to happen. How that gear shifting is going to happen? The gear shifting is going to happen with the help of the fork mechanism. It is called as a selector fork. Selector fork. Okay, and you have the dog gear or dog teeth dog gear, which is used to mesh between the gear to that of the splines or the gear dog gear basically. So this is the dog gear. So you can see you also have the dog teeth on inside of the dog gear, and this dog teeth on also is basically when there is continuous mess going to happen. What happens is there will not be any damage to the gear. The gear will not get damage. Even if there is a damage, only that the dog teeth will get damage. Only the it has some two teeth. Okay, even to replace this, the cost is going to be lesser, and operation is also not that much uh, noisy as compared to the sliding gearbox. Okay, so you have the selector fork slides, dog gear backwards, and this moves and the spine shaft in which there is an engagement going to happen between the dog teeth and also the gears. Okay, in the case of reverse gear, what happens? I told you there is idler gear. So this is the lay shaft. Okay, this is the lay shaft, and which is connected to the input shaft of the gearbox. Sorry, the clutch, and it comes. The power gets the gear gets moved here, and in fact, idler gear will be in mess with the lay shaft. When this moves in the clockwise direction, this moves in the counterclockwise direction, and this also moves. Finally, this also moves in counterclockwise direction. Okay, which means counterclock is basically a reverse one. Okay, so where you are going to get a reverse operation. Okay, so this is basically first gear operation. So this is the input shaft, this is the lay shaft, and so this is the output shaft, this is the just a second. So this is the output shaft, and you see here in the case of first gear how it looks. So the clutch housing connected to the engine flywheel. Okay, you have the friction plates getting engaged. Okay, you can see the dog gear getting engaged with the first helical gear. Okay, and this is the lay shaft. Okay, and this is the dog gear which is engaged with this dog gear moves towards this direction. Okay, D1. So you have D1 and D2. Totally two dog clutches are there, right? So two dog gears are there in the case of constant mesh gearbox. So this moves when this moves towards this direction. What happens? This messes with this gear, and finally the power goes to the output shaft. This is the case in case of second gear. Okay, let us see the difference between the sliding mesh gearbox and then the constant mesh gearbox. Okay, it consists of a spur gear, the sliding mesh gearbox, whereas it consists of a helical. In the case of constant mesh gearbox, we have the helical gear, and the main shafts are not in mesh. Here you have the constant mesh, and you have the selector fork unit to operate the gears. You have the dog clutch unit in the case of constant mesh gearbox. And the size of the gearbox is also very large in the case of sliding mesh gearbox. It is going to be less when compared to that of sliding mesh gearbox in the case of constant mesh gearbox. And because of the sliding, what happens? The noise is higher in the case of sliding mesh gearbox, and the constant mesh gearbox is going to be quieter in operation. And the wear is going to be much higher, and the wear is less in the case of constant mesh gearbox because of the the dog gear. And basically this sliding mesh gearbox cannot be used for high speed ratio, whereas this constant mesh gearbox can be used for higher speed ratios. And this sliding mesh is outdated because this is oldest type of gearbox, and this constant mesh gearbox has been used in 2 and 3-wheeler application. Next you have the synchro mesh gearbox, where you have a synchronizer between the gears. Okay. Whereas in the case of the constant, you have the dog gear, right? So only difference is you have the synchronizer gear. That's the difference between the synchro mesh and the constant mesh gearbox. So the power remains same. It moves in the same direction like that of the constant mesh gearbox. This is the neutral gear. This is for the first gear. But in the case of first gear, there what happens? The dog clutch D1 moves towards left, towards the right. But here the synchronizer moves towards the right. So first synchronizer moves towards right, and the the power ratio means the power transmits like this. And in the case of second gear, what happens? The synchronizer 2 moves towards the left, and the gear ratio is going to happen. And similarly, in the case of third gear, the synchronizer 2 will move towards right, and you get a power transmitter in this direction. And in the case of fourth gear, what happens? This is going to be a direct drive, similar to what we have seen in a constant mesh gearbox. And you see here also you can see the synchronizer is moving towards left, and it has it's going to have the fourth gear where it is the direct drive. And the last is going to be the reverse gear, where the idle gear comes into picture, where the counterclock direction is going to happen. Finally, the reverse action is going to happen. Reverse movement is going to happen. So this is how the typical synchronous gearbox looks. You have the male cone, female cone. This is a synchronizer, where the complete engagement is going to happen during action. So this is a typical model of a synchronous, where it is having the concept synchro collar. It engages the concept. It is basically male cone and female cone. Similarly, what we have seen in a cone clutch, you also have here. It's called synchronous, but here you have a male friction cone and a female friction cone. And this is how the typical synchronizer looks. You have the main shaft. This is the main shaft. This is the synchronizer hub, and this is the gear. This is the teeth, dog teeth, and you have the cone. Okay. What happens here in the case of constant mesh? You don't have a cone, whereas here. Okay, so this is the comparison of a sliding versus constant mesh versus synchro mesh. Okay, the parameters includes, these are all the parameters, like when for a gear changing application, the sliding mesh is going to be by gear, and constant mesh is going to be by dog clutch, and synchro mesh is going to be using the synchronizer. And the gear used is per gear in the case of sliding mesh, and in the case of constant mesh, you are going for a helical gear or a double helical gear. And similarly, in the case of synchro mesh, it is going to be double helical gear and helical gear. And the skill required by operator or a driver, it should be higher in the case of sliding mesh gearbox, and also for a constant mesh gearbox, and less skill is required for a synchro mesh gearbox to get operated by the operator or a driver. The power loss is going to be higher in the case of sliding, and less in the case of medium in the case of constant mesh, and the synchro mesh is going to be lesser. And as I said, sliding mesh is going to be higher noise when combined with of constant and synchro mesh. Normally, synchro mesh has been used in many of the applications in our vehicles, in the car application. And finally, the double declutching is going to happen in the case of sliding and constant mesh, whereas that is not going to happen in the case of synchro mesh, because we have the dog D1, D2, dog clutch, dog gear, which will have double declutching. But in the case of synchronous, those things are not going to happen. Okay.